Okay, dear student, let us see what are we going to learn in this video. In this video, we are going for the circular motion, and let me explain you like why are we moving into the circular motion now, what is happening, and what is the mapping of the two syllabus, like the new syllabus and the old syllabus. So, in the new syllabus, A2, like A1 is completed. A1 is all about the kinematics, translational kinematics, and that we have completed. In A2, we are going to study two things. Number one is the force, and number two is the circular motion. So I see it in a different manner. I will let you know. And from the old syllabus point of view, sorry for the bad handwriting now. So for the old syllabus, this force was the topic 2.2, and 2.1 is the kinematics, which we have completed. So topic 2.2, and the circular motion is covered in the topic 6.1. But in the new syllabus, it is added into the mechanics only. Now, why they have done it? Because the topic A3, I think A3 is momentum, A4. So the topic A4, we are going to discuss the rotational dynamics. Rotational dynamics. This is what we are going to discuss. And in the old syllabus, the rotational dynamics was only completed in optional B, which is engineering physics. So earlier in the last syllabus, that is May 2024, we were not doing rotational dynamics, like all the students were not doing. Only the students, those who were opting for option B, they were doing that. But now every student in IB is supposed to go for rotational dynamics, which is a very difficult part. Indeed, I must say that this topic is one of the most intriguing, and it's kind of difficult. If you know the concept, definitely nothing is difficult for you, but still we can say it's hard. So, but this rotational dynamics is intricately related with the circular motion. So, if you want to add the rotational dynamics into the syllabus, you can't go there without learning the circular motion in the first place. And this force, now again, mechanics is the branch of physics that deals with the bodies in the motion or in the rest, which is divided into two parts. But one is kinematics and another is dynamics. Now, kinematics is the branch which talks about the SWOT equations, but it does not consider forces. Like we say that fine, the bodies are undergoing so and so accelerations. Why? We don't care about that. But in dynamics, we find the forces first, and then we apply F is equal to m into A to find the acceleration. So it is the dynamics where force comes into play. Now, this kinematics, it is divided into two parts. Number one is translational motion, the motion which is done in a straight line. So all the SWOT equations that we have done up to now, and we did the projectile motion and all that, they can be regarded as a translational motion. Okay, that we have done. So this part of kinematics is completely done, and that is the point A.1 you can say, or 2.1 you can say. So this part is completed. Now after this, there is a translational, sorry, there is a circular motion also here in the same bracket. You can call it circular motion. Now in this part of circular motion, which we are going to do here in A2 or 6.1, in this we do not consider the rotational forces. We only consider the accelerations, rotational velocity, like circular velocity, angular displacement, angular velocity, angular acceleration, tangential acceleration, and also the SWOT equations in the circular motion. So that in the earlier syllabus it was not added there, but in the new syllabus they have added the kinematical equations into the circular motion. So we will be looking forward to that. In the dynamics part, we do forces, Newton's laws of motion and all that, and which is the topic 2.2. Yes, obviously 2.3, momentum and impulse is also included in that. So this is part which is known as a translational dynamics, in which we are going to cover the forces, and that dynamic part in the circular motion is known as rotational dynamic. Rotational dynamics does talk about a force technically this is not a force, but it is kind of replacement of the same concept. In the translational motion you need force, you need something like pulls and the pushes, so the body should move. Similarly you need torque to rotate something. So if you are rotating something, that is not called force, it is known as torque. So in the rotational dynamics we would be talking about the torque, we would be talking about the angular momentum. Like here in 2.3 we were talking about the momentum, so here we would be considering the angular momentums. Obviously angular velocity and others we have already discussed there. So we would be talking about the forces also, that is the angular force, which is torque. Okay, so this is the rotational dynamic. Now this is a.4, this is 2.2, 2.3, and this. So this part we have completed. Now we are moving into the circular motion kinematics, which is A2 and 6.1, which is a very small topic, so we can complete it in 1 or 2 videos. That's it. And then we would be moving into the forces first of all. And forces is a very big unit, and we would be consuming so many lectures there. I can't even tell you how many. Like I expect them. Rotational dynamics again, it would be very big lectures, so that would be taking a lot of time. So let us now quickly move to the circular motion without wasting any time. You people can take the screenshot for this if you want to understand the mapping between the old syllabus and the new syllabus. Let us now move to the circular motion. So before we go into the circular motion, let us talk about angle first of all. What is an angle and how it is defined, what are the units, each and everything. It's very, very important. All the formulas of the circular motion, they are dependent on the angle. That is why. So let us say there is this circle, like this, and let us say there is this kind of angle which is subtended at the center. This is theta. This point is A, this point is B, and this point I can just call it C as the center. So yeah, this is what is happening. So this is angle. Now what is most important thing in angle, like you already know what angle is, the units for this. Now what are the units for the angle? I'm directly going to the units. So the first unit that you know is degree. So degree is like 30 degrees, 60 degree, we know it. 30 degree, 45 degrees, and 60 degrees, 90 degrees, that degrees. So degrees is very easily defined, like one complete circle is divided into 360 parts, and one part is called 1 degree. That's it. Now this is 1 degree. 1 degree is further divided into, like if I divide it by 60, it becomes 1 minute. Okay, if this 1 minute is further divided into 60, it becomes 1 second. This is important from the point of view of astrophysics, because we would be defining many units at that time, and that astrophysics has been added into a simple syllabus in the new syllabus. So that is covered in both like old syllabus as well as the new syllabus. So this is one double dash, so that is seconds. So it is very, very important to know it. 1 degree divided by 60 is 1 minute. 1 minute divided by 60 will become 1 second. That's it for the degree. But point to be noted, this is not the SI unit. What is the SI unit? SI unit for the angle is radian. Radian. Okay. Now this is radian, but how is it defined? Very cleverly, scientists have created this thing. Like you might ask me, like why the degree is not taken to be as a SI unit. The reason will be very clear when we are going to learn what is a radian. So radian is defined as the angle subtended by an arc of length equal to the radius of the circle is called 1 radian. That is called 1 radian. So this length, if I say, let us say this length is L, AB, and if this AB is coming out to be equal to AC, that is the radius R, I will say that this theta is equal to 1 radian. Very cleverly, the scientists have related the circumference of the circle with the angle. In the case of degrees, that is not done. They don't know how to relate degrees with the circumference, so they related the length with the radian, and they defined it like this. Obviously, if we say that, okay, fine, what about if we are having two l's here? Let us say there is another L here, and I define this point as D. Now, what will be the angle? Obviously, this angle will be another theta, so that will become 2 theta. It means 2L is giving you 2 theta angle. So, we created a formula out of it, and that formula is L is equal to R theta. You people might have seen this formula many a times now. You people might have used this formula so many times now. But I believe that the concept could be like you might not be knowing this. So L is equal to R theta. So L is the length. Whatever is the theta, you can substitute the values here. So double is the theta, so double will become the length. From there, we are getting the formula L is equal to R theta, which is very, very important for us. Well, it has a vector formation also, but that is actually not required. But it is kind of S is equal to theta cross R. Yes, theta cross R. But vector notations are not required for you. Otherwise, like we do these kind of things also in India, but that is not required as of now in IB. So, yeah, this is done. This is about the circle, first of all. So now we know that there is a relationship that exists between L and theta, and that is L is equal to R theta. Now I am erasing this thing. And you people, if you want to see it again, you people can pause the video, you people can go back and watch whatever you want. Now, let us move next now. So the next point, now we are entering into the circular motion. So the first point that we are going to discuss is the angular displacement. Now, what is angular displacement? Obviously, it is the angle which is traversed by the body in some time t. Obviously, it is the angle by which it is moving on the circular circumference. So we can clearly say that this angular displacement is just delta theta. So theta, we are not going to call it angle now. We would be calling it angular displacement because we want to talk in the terms of motion, circular motion. So it is angular displacement. So the angle which was traversed is angular displacement now. So delta theta is here. So the relationship between them is delta L is equal to R delta theta. Yes. Where L is the distance that was traveled here. Yes. Okay, having said that, let us directly move to the second point, which is angular velocity. So angular velocity is how much angle are you traversing per unit time. So it means that the same equation have to be divided by the time on the both sides. So we are dividing this by time. Delta theta by delta t. So delta L by delta t is, you can say, the velocity or the tangential velocity or the linear velocity. Let me explain you what this is. So this is the omega, like what is the angle that you are traversing in some time, and the distance here is the L length L. So what is the velocity here? So velocity will be shown like this. Now, this velocity, this is v. This can be taken as velocity tangential. Tangential velocity means the velocity along the tangent to the circle. Or it can be called linear velocity because it is in the straight line. One is the same thing. Don't get confused like what is tangential velocity, what is linear velocity. There are so many names. Physics is fond of that. So I would be explaining you so many things later also, that there are so many names, but it is the same thing. So this is the velocity, and you can call it tangential velocity or the linear velocity. So this is V is equal to R omega. So you have seen this formula also thousand times now, and you might have used it now, but this is how you derive the formula. Now we want to talk about the angular acceleration also. Now try to understand what is the basic difference between the tangential velocity and omega, the angular velocity. You just imagine about a fan. Now fan is moving. Can you say that what is the velocity of the fan? I will say that fan is not even changing its location. It is at the same location. Fan was there and it is not moving. So how can you say that the velocity of the fan is there? Because it is not moving, but it is rotating. So we cannot use meter per second kind of unit. We have to create a unit in the terms of angle. Like in how much time is it covering one circle? In how much time the wings are covering one circle? So 2 pi angle has to be rotated in the time. That is why we will define omega. So this is v is equal to r omega. Now let us go to the angular acceleration. Angular acceleration is, now again we are going to divide the this same equation with the time. So this will become a is equal to r alpha. Again, this a can be written as at, just like this vt. So this is called tangential acceleration. Very, very important. Please don't get confused here now, because we would be introduced to many type of accelerations in the circular motion. There are three types of acceleration, although. So we would be going for the centripetal acceleration in the next video. So two type of acceleration I'm just telling you now. This is called tangential acceleration, and the unit is meter per second square. So because it is just the variation of the linear motion, so this is vt here, this same is at, and the same will be the st or l. Okay, st or l is the same thing. And here you are having theta also, omega also, and the alpha also. All of these three things, they are shown at the center of the circle. This alpha is called angular acceleration. Like you can think of a fan. The fan is moving and you say that no, I'm not feeling the wind, so I just want the to increase the speed of the fan. So when you increase the speed of the fan, so it was earlier moving with omega 1, and now it is increasing and it will become omega 2. So it is increasing now. So once it starts increasing, that is the angular acceleration. That, yeah, it is taking some time to increase its omega from omega 1 to omega 2. It is taking some time. That is called angular acceleration. Obviously it is going to have a relationship with the linear acceleration. So we can say that our tangential velocity earlier was 1 meter per second, now it is 5 meter per second. That is the tangential velocity. So I believe this is good to go with. There are a couple of things more to say, but what is the time now? Is the video long enough? Oh my god, it is 20 minutes now. Okay, no problem. 17 minutes. So I would be taking a couple of minutes more. Okay, so you see, in this, what happens is, uh, now as we know the alpha is also there, let us now create a comparative SWOT equations. Translation motion and the circular motion. So translational motion, the first SWOT equation. Okay, I'm just creating the comparative analysis there. So displacement. So here the displacement is given by s, in the circular motion it is given by theta. Point number two is velocity. In the translational motion, the velocity is written as v. In circular motion, it is written as omega. Point number three is acceleration. Here it is written as at, vt, like that. And this is written as alpha. Okay. Now we're going to the SWOT equation. So the first SWOT equation is v is equal to u plus at. So we can say that earlier it was moving with omega naught. Now the angular velocity is omega. Alpha had been the acceleration multiplied by time t. Complete replication of the SWOT equations from the translational to circular motion. Point number 5, S is equal to ut plus half at square. So S is the distance traveled, which is displacement is now replaced with displacement. U is replaced with omega naught. A is replaced with alpha t square. Very good. Let us now move next. Point number 6, v square minus u square is equal to 2as. Final angular velocity is omega, initial is omega square 2 alpha theta. Isn't it? In place of a, we are just replacing alpha. In place of s, we are replacing it with theta. So it is omega square minus omega naught square is equal to 2 alpha theta. So similarly, we can create as many formulas as you want. We can create this table. Later, we would be creating this table in the case of rotational motion also, and I would be telling you what is this. Okay. Yes. So in this video, it is only up to this, and I think that I've given the concepts majorly. So when we would be doing more questions on this, the things will become even more clear. And I am always present with you on the YouTube channel, also on the WhatsApp. So you people are always in contact with me. You can ask anything. Okay, dear students. So please share the video and tell all the other students, your friends, to join the YouTube channel. Okay. Okay, then. So after this, we would be moving into what? In the next video, I don't know what I'm going to do. But anyways, we would be doing something good. All the best. Bye.